Hi everyone, and welcome to our latest PVTech TechTalk Product Series webinar. This is Mark Osborne, Senior News Editor at PVTech and the moderator today. The focus of today's 30-minute TechTalk product webinar is about the recent launch of Ginlong Solis' 1500 volt 255 kilowatt high-powered string inverter. This is specifically designed for utility scale PV power plants. This webinar is aimed at explaining key technology differentiators and compelling LCOE metrics to the new era of high-performance modules. Joining us today will be Pedro Weissman, Sales Manager for Solis Europe, and Gary Lamb, Head of Utility Business for Solis USA. Just a little reminder here that we will still have time for a short 10-minute Q&A session after the presentation. So feel free to post questions throughout this webinar. We also have Solis staff on the webinar to help answer any questions you may have. Okay, that's it for me at the moment. So once again, we have a lot of great info to get through today. So if both presenters are ready, Pedro, you can start now. Thanks very much.
Thank you, Mark. Thank you so much for having us here. I'm a big fan of PVTech and I always enjoy your tech talks. I think some of the most professional webinars in the industry. It's really an honor to be here. And yes, you're right, the industry never stands still. It is always evolving. And for example, since I started in renewables in 2006, I have already witnessed a few changes. Even we, and I mean Ginlong, we have transformed our business from a wind energy company to a solar one. Some people might have come across Solis inverters just a few years ago, but Ginlong, the company behind the brand name Solis, was established already 15 years ago. Well, as a matter of fact, we just celebrated our 15th birthday a few days ago. Ginlong started manufacturing inverters for wind turbines, and maybe some will be surprised to learn that in 2015, the inverters installed on the Eiffel Tower in Paris are Solis inverters. We have grown our business in solar so much that we are now a listed company in the Shenzhen Stock Exchange market, which gives us an incredible financial support and bankability. We are present worldwide and are now enlarging our factory in Ningbo into a 20 gigawatt a year string inverter factory. As shown on this slide, we have quite a few third-party endorsements that speak about the quality of our products and the bankability of the company. This is especially important when speaking about utility scale project because, and don't get me wrong, I joined renewables because I wanted to do something to help with the environment. So oil and gas was out of the equation. But I'm long enough in this to know that when speaking about utility scale solar projects, our inverters become a financial product. And here it is where the evolution you mentioned, Mark, is bringing string inverters into the forefront, especially because of financial reasons. If you follow these lines on the graph from left to right, what is the time axis? You can see it goes from the year 2010 on to the left to 2023 on the right. The price of inverters have dropped dramatically, like of course all other technologies in solar. But string inverters, which is the orange line, has dropped even more than central inverters. Therefore, nowadays, there is no cost difference when purchasing X amount of watt with a central inverter or with a string inverter. But there might be several advantages and therefore overall cost benefits when designing a utility scale project with string inverters. My colleague Gary Lamb, who is an expert in the field and has been designing utility scale projects for now over 10 years, will explain all this much better than I do. But just for the financial guys out there that are listening to this webinar, let me just mention a few points that, depending on the project, might make a design with string inverters a much better financial decision. String inverters have a high DCAC ratio, which allows to install more module watt power, which again will increase the yield. Also because string inverters have an extremely low starting voltage, they begin to produce energy early in the morning and also do this until later in the afternoon, which of course produces more. If we add the MPPTs, where against the central inverter, we are tracking the point of maximum power for each 2 strings. Then you can clearly see, and even if we use bifacial modules, which benefit so much of having more MPPTs, you will see that the yield of that installation increases a lot. And that was only the energy production part of those huge Excel files developers and promoters use. We also have reduction in CAPEX, as for example, we get rid of the junction boxes, or we can reduce the cost in the power lines by changing the DC cables for AC cabling, which is cheaper. We can eliminate communication wiring by adding the data flow through those same DC cables. By the way, those changes also reduce installation time, which, depending on the labor cost of each country, can be particularly important. And O&M, of course. O&M costs can be reduced too. For example, in the improbable event that a string inverter fails, and really, I don't want to enter into much detail here, but these machines are a bit like Panzers. They have the best quality components inside, IP66 protection, redundant cooling, and so many more things. If someone is interested, I think we can share the summary of the DNV report we just mentioned before, that not only prices the track record, but also states that the life projection of our inverters exceeds market standards. But as I was saying, if a string inverter fails, you just swap it for another one and send the defective one to us for repair. The downtime of that inverter, and therefore the loss of production of those 255 kilowatt against whatever you have on your central inverter, if that one stops working, the loss of production of that inverter will be reduced to whatever time your O&M team requires to perform that swap. But enough from my side. Let's hand over to Gary Lam and dive deep into the interesting part of this presentation, because Gary has a much better technical knowledge about all this than I have, and I've been just blabbering around here. So Gary, please take over.
Thank you, Pedro. Thank you. And thank you, PVTech. It is an honor. As Pedro said, I live in the US, and I've been working on this utility project for quite some time. I've always been with a microinverter and string inverter company for the last 10 years for doing utility projects. So hopefully today I could share with you some of interesting view I have. First, I would like to share with you some scenario. We are working with a 3 megawatt central solution here. If you look at the chart, this is a 3 megawatt central solution. We'll be able to see what typically is 26 module per string, 14 DC combiner box. If you could follow my laser pointer, 14 DC combiner box, which I assume your DC combiner box will have a standard 24 strings input. And then we'll go through this DC power line to the inverter, and all this DC will get merged at the inverter and then to a transformer. And we will have data line coming from inverter, coming from transformer, or into communication box to your monitoring device. One thing I want you to pay attention is through this DC power line, there's no data flowing through, right? So now, how do we convert this 3 megawatt central to string inverter, especially with our Solis 255? First thing, very obvious, we want to remove the central inverter. And then next, I want to pay attention at the DC combiner box. This is where the trick come in. We will swap those DC combiner out directly with their existing locations for this 255 kilowatt inverter. Look at the number. We reduced the amount of 14 DC combiner box to 12 Solis 255 kilowatt, thanks to the increased string input at 28. Now, this is the most critical part. I'm gonna talk more into it on my next slide, but let's keep it as it is now. So after we have installed the string inverter at these locations, the cable coming out is no longer DC. So we will change it to AC power line. And then we will need a merging device. We will add an AC switchgear to combine all this AC wire in. If you realize there's an AC wire coming out and going into a smart communication box, and that is not an error. We have implemented so-called PLC, the Powerline communication technology, to allow data to transmit through the power line. Now, the AC power line coming out from the inverter have all this string inverter and grid data that got sent to a centralized location at the AC switchgear and will collected by the smart communication box. One of the benefits is also your monitoring system. You either choose to use Solis or any third-party monitoring system will treat now the site as one central inverter. So for communication-wise, there's no difference with your existing central communication topology. And last, a lot of us, including myself, always forgot, there's an inverter skid that we had where we took out the central inverter, but the skid is there. Actually, the skid is not required. Also,
I was going to ask you, Gary, what happened to the skid, because all our customers are asking for skid also for string inverters.
Oh, okay. Yes, I thought I just got that question in the US, but apparently Pedro in the Europe also got this a lot. Yes, a lot of customers have asked us to provide them with a skid quote. I think what they usually means is a transformer with built-in inverter. But as you see, our Solis 255 do not require to build that inverter next to the transformer. The inverter already replaced and installed at the DC combiner box location. So there's no skid to build. If you look at that, a skid is a central terms only. And actually a skid is quite costly to build because your central inverter manufacturer will only manufacture inverter and the transformer manufacturer will deliver your transformer. Somehow you will have to put it on the site using your own labor or have a third-party integrator contractor to build this off-site for you and deliver to the site, to the job site. The labor of putting this together and the delivery is very costly because once it's built as a skid, this thing is very big and heavy. So by reducing the skid, we have done some study saying on average, it will save you $10,000 to $20,000 US just by not installing the skid. We'll get rid of the skid. So it depends on how big your project is. I'm using a 3 megawatt subarray as an example here. So if your project are 10 megawatt, then you will be able to save 3 to 4 times the saving. If your project is 100 megawatt, then you will be able to have almost 30 times the saving. And this number add up very quickly. Now, let's talk on how this inverter will completely replace a DC combiner box, which usually be the challenge of other smaller size string inverter. Looking at the DC combiner box, it usually have 24 string input, require fuse or breaker, uses OD terminal that require regular torque check. AFCI is always additional to what existing cost is, and string monitoring is not included. So we don't want to use it. Now, once we replace with the Solis 255 kilowatt, what you will get is a 28 to 42 strings input device with fuse free. What does that mean is this: when you install this, you do not need DC fuses. It's not required no longer. AFCI built in, as well as string monitoring. And from the string monitoring, you will get IV curve analysis, a remote IV curve analysis. This unit is DC coupled storage ready with built-in MC4 connectors, which is pre-terminated, easy to replace, and that require no torque check. The whole unit is IP66 rated with anti-BID built in. If you have questions about anti-BID on our 255 on how they use it, I usually got that question quite a bit. So let me just explain a little. On our inverter, we have built in the anti-PID device to raise the ground voltage of the DC side. So we make sure your module will never experience a negative voltage. So the current or the electron will never flow backward towards the module. And that help actually reduce the degradations that could happen to your module. Next, Pedro mentions our 255 is a feature-rich device that could have just too much function to talk about. But a few points that we want to emphasize is DC-AC ratio, right? We support a standard 1.3 to 1 DC-AC ratio, and that's very popular in the US. So in the Europe, you might fit in that number. Anything less than 1.3 is pretty standard. But what makes us different is our 1.3 to 1 DC-AC ratio. We can achieve that ratio using currently available modules starting from 430 watts. If you are comparing this to other modules, you will see that other competitor may not be able to reach the same AC ratio until we have 500 watts or more modules. And our maximum supported ratio is up to 2 to 1. We support 200% over ratio for your DC-AC. Right. Also, Pedro mentioned an ultra low starting and operation voltage, and that actually contribute to the inverter to working early and until very late in the evening. And that actually gives you that very nice little curve on the yellow that is the additional productions that you will receive. Next is our PLC communication. I also got a lot of questions asking it. The PLC communication enable you to create a cable-free communications path. It is very reliable and high speed because the signal is transmitted through the power line. And the power line should be the most reliable things on your site, right? This is your revenue generating line. And then the speed of the PLC due to its higher voltage operations, it achieved almost 10 times the speed of RS-485. So all this string information, inverter information, module information could all transmit through the power line communication. And the most important, most vital things is it creates a parallel communication path. Unlike our standard RS-485, it uses DC chain connections to connect one inverter after another. Parallel communications enable the signal to reach each individual inverter at the same time with the lowest latency. And that is very important to enable our future smart grid or smart utility requirement. Next big thing about the 255 is we are future-proof for the storage and is storage ready. Our compatibility with storage is exceptional. As you could see, most of the AC energy battery, we all know, have the flexibility to work around, and it will be compatible with any system. So I'm not going to talk about it. So mostly on the DC side is what I want to emphasize. Our unit has built-in a DC connection bus to connect any third-party DC-DC converter with battery, or we call it PCS with the battery. As I mentioned earlier, the inverter have already taken a lot of approach, including most importantly, the DC-AC ratio. We allowed you to connect as many DC power as you need into the inverter to enable charging to the battery. Right? The benefits is very obvious. We have integrated that storage functionality so that you could design your PV now and think about storage later on without worry about how to upgrade. Now, some of you may have to force to go into AC storage system by no choice because your inverter simply do not support. And if you want DC, you might have to even swap out the inverter. Now we leave you both options open. Very easy, very flexible to work around. Last is the maintenance-free O&M with higher temperature and environmental tolerance. Our inverter are built, as mentioned earlier, with IP66 rating, right? But still provide you a very high efficient cooling with a redundant fan control that will operate up to 60 degrees Celsius. it is a soft shut off. It doesn't mean it cannot go higher, but for safety, we protect the inverter up to 60 degrees in ambient temperature, right? So primary cooling method is the passive convection cooling, also called conductive cooling. All the heat are conducted to outside and moved by the natural wind to dissipate all the heat. But we added the secondary cooling with a weatherproof active fan that comes with 70,000 hours of lifespan. That is equivalent to almost 30 to 40 years of operation.
But Gary, sorry for interrupting.
Yes, Pedro.
If my maths are correct, 70,000 hours, that makes not 25 years, maybe 5. So are
yes.
the numbers wrong?
Yeah, no, the number is right, but look at it this way. You're probably calculating the 70,000 hours with 24 hours a day. But if we look at the PV inverter, the inverter actually operates, peak as 8 to 9 hours peak, but taking in account of the effective solar radiation and our fan, the active owned by temperature, that our fan in this unit will only operate probably 4 to 5 hours a day. And if you divide that 70,000 hours by 4 or 5, that actually give you quite some time to play around with. So this is how we guarantee a 25 years maintenance-free solutions to you. Combined with all I have mentioned before, right? We have no DC fuses. We have no torque check. You don't have to torque check any terminals. We don't have filter. We don't have fans that you have to constantly maintain. So we ensure you a 25-year maintenance-free inverter. And this is some installation practice. We have already deployed some of this unit in a field site in China, and you can see on the graph on the top right here, we can see that there's actually a post, 2 posts here, individual posts for mounting this inverter, which also on the bottom, we can see that this inverter is mounted to the array rack by adding this 2 unit strike to install this inverter. So any way you want, this inverter can install easily anywhere and flexibly at your job site. You could either add a post or mount it directly to the racking. Next is even better things for IV curve scanning. A lot of us are familiar. IV curve scanning is usually deployed for determining the module condition, right? How are my module performing and how will they perform next year? So with our smart IV curve scanning, we provide you with a 1-key online scanning. What does that mean is at your office, at your fingertip, you could just click a button and perform the IV curve at your comfort. You no longer have to deploy the whole operation team down to the field to run that scan. It is also non-stop. What does that mean is for traditional IV curve scanning, you will have to shut off your site for a couple hours to a few days, depending on how big your site is. That actually you will lose power by performing IV curve because of safety requirement. Your tech guy need to be on site. But with ours, no personnel need to be on site. So inverter, when you hit the button, inverter will take turns one by one. It performs the IV curve, shut down, do all the tests it needs, and then will come back on. And then the next inverter would take turns to do that. So one by one, as string inverter already using a distributed design, losing one inverter during the day will not have no power impact or very minimum power impact to your site. Therefore, it is efficient. It saves you not only time, but also labor costs, and it will be a great benefit. That's it. I think I've done a brief job for the solutions, and hopefully that is helpful with you on how to change your central design to 255, or simply just installing the site as new with Solis 255. Thank you very much, and I will pass it back on to the team.
Thanks, Gary, for this straightforward presentation, which clearly shows we are again entering a new area in PV evolution. and that engineers, developers, EPC companies should rethink the way they design a PV plant, because they might find that they cannot only reduce the capex, the cost of building the plant, but also improve their OPEX, the benefit they get out of it during those 25 to 30 years, just by designing their projects with solid string inverters. And well, I think this finishes our condensed presentation about the 255 kilowatt string inverter from Solis. Mark.
Well, thank you there, Pedro. Thank you there, Gary. Really good stuff. Really enjoyed that. There seems to be quite a few questions that center either on the energy storage side, and I know, excuse me, Gary obviously wanted to talk more about that, but you know, in the time frame we didn't. I hope you may be able to cover a little bit of that in a moment, Gary. The other side was, you mentioned this as well, was about the PLC. So maybe let's start there, Gary. Just give one of the questions was looking at the kind of interference or you know, restriction potentially with the PLC. Maybe give us a bit of confirmation on that, because it's quite unique, your approach to this.
Yes. So the Powerline communication is not anything new. We have been using it for quite some time, including our home. Some of us might be using a Powerline transmitter Ethernet. That just it's just a technology that put the signal on the power line. So same thing with ours. A lot of people, if we have worked in the past, which we have been in the solar for a long time, there's a lot of company try to introduce PLC technology for our home or office project, and they find out that doesn't quite work well. The reason is being the signal is injected into the AC voltage line, right? It creates a voltage, a slight distortion to transmit the signal through. And what happens is if we have a lot of nonlinear load in the site, for example, in our home, obviously we have our air conditioning, our fan, and then in our office, even worse, we got all kind of things coming in, and that will distort the signal badly. So for the PLC to work, ideally we will want a pure site that does not have a lot of noise. A PLC have certain noise tolerance, but not to a certain level. But for us, if the Solis 255 is designed to use in utility project, that basically means the whole site only have PV and nothing else. And our inverter output such a clean AC waveform that do not include any noise on it. So the PLC signal could transmit within the site very nicely. And at the end, our large voltage transformer will act as a big LC filter and just filter out all this signal. So this is why we need to install a PLC CCO device before the transformer, and to keep all the signal. And the signal will not go beyond your mid voltage or high voltage transformer.
Cool. Thank you, Gary, for that explanation. Maybe a slightly easier one. Obviously, you focused on highlighting the high temperature environments, the ambient temperature side, and the uniqueness of using the fans, but supported really as a backup. But a good question was regarding what's the coldest temperature range that the string inverter can operate in.
This inverter is rated down to -20 degrees Celsius of operating temperature and -40 for storage purposes.
Something rated as well was someone's just put in there about is this inverter CE rated yet, certified? So I'm assuming.
Yes, I think Europe team will answer that question, but I actually received a certificate. Yes, the unit does have a CE certificate already. Yep.
Okay. Obviously, we touched. Let's go to the other big theme here from the questions, which was on the energy storage side. lots of people saying, "Oh, what's the how does this type of inverter manage the energy storage facility capabilities?" What's your bottom line on this? Because you're highlighting a highly flexible system here. But what would be your best advice?
Yes, our inverter is designed on the storage applications mainly around that. So this is one of the reasons why the very high DC-AC ratio come into play. And the method of connecting DC is we have a DC connection port on the side of the inverter that tap in directly to the DC main bus after the MPPT. So a third-party battery and a PCS power conversion system, normally we know it as DC-DC optimizer or converter, will connect directly to that bus. That DC bus provides you a very stable DC voltage that is easy to work with any PCS system, any DC-DC converter, and depends on the third party who is providing the DC-DC. The battery could be really flexible. So we are not trying to bundle any battery into our system, but we leave that choice to you. You can choose any battery that you want to work with. And as I said, we provide you with a very a stable DC voltage connection bus. So the job for the PCS is very minimum.
Okay. Actually, just related to that, just a quick one that's come in, and I'm looking at the time as well, so we've only got a little bit left. Can you confirm that your inverter can work at night, generating reactive power to the grid?
Yes. This inverter does support nighttime VAR generation. Depends on region. So in Europe, likely this is open. In the US, it really depends because that's about the utility requirement. Yes, but this unit support nighttime VAR generation.
Okay. One final question, if I may. Someone asked about with the string inverter, does it come with 28 string input or the 42? So you mentioned in a slide you're highlighting its capabilities there. Perhaps explain that a little bit more in depth for us, Gary.
Yes, our inverter comes standard with 28 strings inputs and could expand to 42 using Y branches. So the standard is 28 strings.
Yeah, just one final related to this. So how many inverters can work in parallel?
Currently, I think the system would work up to 50 or more. But right now we are working on the largest solutions we're deploying is about 6.3 megawatt, and it hardly reach. It's just about that, yeah. And that should be plenty for us. The limitations on the inverter is mainly on the communication side, how much our communication support. But that doesn't affect by the power, AC output, or harmonic, anything like this.
Okay. Well, Gary, Pedro, thank you so much for this interesting product series webinar. Really enjoyed it. There's still some questions coming in, and I just want to let attendees know that Solis people will be online, even though we're finishing here. They will be on the platform. Give them your details so they can follow up with you afterwards. And once again, thank you for this great presentation, and thanks again for everybody coming to this webinar. Okay, that's it. Thank you very much.
Thank you.
Thank you, everyone.